Hello, I'm Chris DeChambeau, and my partner here is Brandon Antizana, and we are Team AVTECH. And we are working on building a digital particulate sensor for room alert. AVTECH is a computer software and hardware company which builds room monitoring systems. These systems come in all different shapes and sizes, as you can see here, and they are very popular in the industry and sold in over 180 different countries. The different kind of sensors that can hook up to this room alert vary between temperature, smoke, flood, airflow, motion, and room entry. However, they are lacking in one department, which is air quality. Our goal is to create a digital particulate sensor which can communicate with room alert. They are in very high demand right now in the warehouse industry due to the fact that those warehouses are filled with high levels of particulate. This causes safety concerns mainly with employees, filter jams, as well as products being damaged. So our goal is to be able to connect one of these to a room alert and make sure the end user can figure out what part of the warehouse is in high levels of particulate and get that area cleaned up immediately. Our best anticipated outcome is a fully functioning engineering prototype of our sensor. This comes with having a working sensor that can circulate airflow as well as have some circuitry that connects everything together. The software side is going to have a PIC chip, which is a programmable integrated circuit, which is going to act as a microcontroller and have a filtering algorithm, which takes in the raw data from our sensor, filters it out, and then sends it over to room alert to be read. Lastly, we would like to put this all in a nice mechanical enclosure for a finished product. A block diagram helps to express a little more what we're trying to do. First off, here's our sensor that is going to take in particulate with the help of a blower, and it's going to be sent out in exhaust. That data that's going to be collected by our sensor is going to be sent over to our microcontroller where it's filtered, sent to room alert, where again the end user can read it, figure out what part of the warehouse is in high levels of particulate, and get that situation figured out immediately. Our key accomplishments so far on the hardware side of things have come with our sensor. First, we had to pick a sensor and we had to test it for a proof of concept to make sure the sensor was going to work. This started with using a microcontroller, also known as our Arduino Uno, which we used because we had one hanging around. We tested it with our sensor, and it proved to us that it was going to work the way we wanted it to. So our next step was replacing that Arduino Uno with a PIC chip because an Arduino Uno would be too expensive and too big to fit in our final product. Once we were able to figure out that we needed a PIC chip, we brought it down to we needed to figure out what kind of PIC chip we needed. So we needed to know how many input and output pins, as well as we needed to make sure it had enough memory to store our smoothing algorithm. From there, we were able to make our schematic, as you can see here. Our schematic led us into this 3D model, which we intend our finished product to look like. As you can see on our model, we have our sensor, our blower, and then our circuitry that goes along with it. We were very happy with our results being able to fit it all on this PCB board because this is something AVTECH already uses. And with that, they already have a housing and a mold for it. So we were able to use their housing and mold. We were able to save money in the long run, which was a big accomplishment for us and AVTECH. Next, I would like to hand it over to Brandon to talk about the software side of things.
Now for the software, I want to use MPLab, which is an application to modify PIC chips, or for testing purposes, I used Arduino. So if you see in the diagram above, you can see the microcontroller pulses through the sensor just so we can grab information of what the sensor sees. Next, it goes to a series of conversions and smoothing algorithms that I have developed in Arduino. And once it's done that, it goes to the UART system and to room alert. So what the UART is a universal asynchronous receiver transmitter, so which is an output console box so we can see data values, which unfortunately MPLab does not have it, but the UART system can actually fill in that gap. Next, for our testing, we used a bin to resemble a warehouse environment, and inside the bin we have a sensor, PCB, and the blower. And for our testing, we used dust and smoke, and we collected data just to see what and to differentiate one another. And to make things even more interesting, we just shake the bin to see any drastic changes that has been previously and to the current tests. Next, I want to emphasize how important the smoothing algorithm is. So in your far left, you can see where raw data is coming in, but as you can see, there'll be certain peaks can cause alarm to room alert, and we don't want that. So for more reliable and more dependable access through room alert, we use a smoothing algorithm which tells the system that a part of the warehouse is polluted and needs to be cleaned up for the employee safety. Next, for our future challenges, we want to replace the microcontroller with the PIC chip, and I cannot stress that enough. If we don't have the picture working up with no bugs, fixes, or any issues that comes along with it, this whole project will be unsuccessful. Because since the picture is the brains throughout the whole process. If we get that working, we need to do some series testings. We need to adjust the codes or implement even more further on to perfect data collection throughout the sensor. Next, we want to test out the blower because we don't want to know if we want to add additional energy, which may cause it overheat. And if it does overheat, it will contact with the temperature sensor that the room has and will actually hinder the sensor data. We don't want that. Last but not least, we want to package all the components together so we can compile and actually house together, as you see in the figure above. So once we have the sensor, the blower, and the circuitry, we want to compile them all together in the house into room alert. And we want to thank you all, people who contributed to our project, and thank you for listening to our presentation.